Right, the main event is somebody said, I don't think I could write a maze solver for the 3D maze. I went, right, bring it on. So, here we are. I was challenged, so I accepted, and this is gonna be fun. So, the plan is temporarily, we're going to build the maze, then get it to solve it, and then we play the game. Yeah, but when we come to the actual game, we're not going to show the user it being solved. Yeah, we're going to get it to solve it, but have it in the background, and then we'll use it as a help mechanism. Yeah. But I wanted to write the code so we could see it trying to solve the maze and see if it did it. Now, I've been thinking about this over the weekend, and I think there are many different ways of solving a maze. There is linked nodes. There are recursive backtracking. There are scanning binary trees, all sorts of different types. Well, we're not gonna do all that complicated stuff because we're in assembly. We're trying to write this in assembly, so it's got to be reasonably easy. So, what I thought was, we do have some code that does the maze solving already, and it's called recursive backtracking, and we use it, and I'll show you where we use it. We use it now. When we build the maze, we are using recursive backtracking, where we go down a route until we've created a random number that says this is the end, and then we backtrack to the next available slot and then carry on doing it. Solving the maze is exactly the same scenario. The only difference is we're not building the maze as we go. We are going to run through the maze and see where we can go and go down it. Yeah? So we can either use left first, right first, or what, or we can just randomize it, get it to randomly pick where to go. So what I thought was we can try and hack to bits the build code and make it into a solve code. So we will try that. So I've got the game maze here, and the game maze here. And what we're going to do is we are going to hijack and copy. Where is it? Here we go, build maze. So we're going to copy that. And we're going to paste it at the bottom. And we are going to call it solve maze. So this is going to be exactly the same. We're going to use the same mechanics as how we build the maze to solve it. And so hopefully when it comes to solving it, it'll be almost, I say almost, as quick as building it. The only difference between the solving and building is when we're building it, we have a choice of where to go. You know, let's go that way. Can we carry on? Let's go that way. Let's go that way. Let's go that way. And then we stop and then we backtrack. Yeah. Here, we're going to be following the maze. We are going to be restricted by the maze. And so if we can only go forward, that's the way we're going. You know, we're not going to be deciding where we're going. We've got to go that way. If we can only go left, that's the way we're going. If we come to a junction with two outcomes, so say left and right, we'll randomly pick one of them and go back. Yeah? So, we need a start point. Yeah? We need to tell where to start. Because at the moment, in the build, we start in the middle of the maze. We divide the width and the height by 2. That gives us our start point and our eventual end point as well. Yeah? But in the solve, we'll be starting up here and trying to get down here. So we need to tell it where to start. Now, in the build maze, we're using maze X and maze Y as our current maze location. So that's where we need to start. So we need to start by saying LDA #0 because I think our column, our X, is 0. So, in fact, let's do this, make it a bit easier. Store X in storage dot maze X. And our start point for our Y, so our row, is row 1 because we're actually one row down in the map. Because you remember, the map is surrounded by a set of characters that say we can't go there, right? So we'll store that in maze Y. That's our start point. Then we have to define our end point. Now our end point in the build is our start point, which was position Y. Yeah. So we need to say position Y. So LDX hash, I think it's 39. No, it's not 39. What am I doing? It's max, isn't it? Storage.max X, and store that into storage.position X, and do the same with maze Y. Store it in storage.position Y. So we've defined our start point, we've defined our end point, so the two different places, right? So as the build, our start point was exactly the same as our end point, and our working coordinates was maze X and maze Y. We're now saying the start point is here, using maze X and maze Y, and our end point is here where we're using position X and Y. And now we're going to have to run through those coordinates and evaluate where we're going. Now, we also need to know where we've been as well. So the plan is to use the matrix array to hold our backtracking, as well as have we been here? You know, have we been here? Yes. But we also need to mark where our route is, our optimal our solution route. So we use bit 7 to store where the user's trail is, which leaves us 3 other bits. Yeah, in the top nibble of the maze. Remember the top nibble? Have I got that written down somewhere? Did I have that written down somewhere? What we're doing? Ooh, can't remember. Anyway, the top bit, the bit 7 in the top nibble is where we've been, our track. So that leaves us 3 bits. So we're going to use 2 bits to say where we're going. You know, our backtrack. Which direction do we need to go when we're backtracking? And 1 bit to say if we've been there or not. It should work. It should work. I think. We'll find out anyway. So, we've started off and we're going to run through the evaluation of the maze as we do with the build. So we're going to store how many... in theory. Yeah, in theory. So we're going to do... basically, we're going to do roughly what we do in build, but we're not going to be building it. We're going to be reading it and we're going to be running down the paths until we get to a block and then we'll backtrace. Yeah? So... we're going to scan how many exits are at that point, yeah? And those exits will determine where we're gonna try next. So as we do in the builder, we're going to say, right, from our point, look at the next point. So in this particular case, look at x plus 1, right? Is it equal to 0? We don't know. We don't know. So, what we need to do here is when we when we get back what we've got to then determine, because we're going right, yeah? We've looked right, yeah? We've got to determine, can we go right? Yeah? So, our point here is, in build, we look ahead. In solve, we're looking at our position. So, we need to change this, right? So, we're looking at our position, and we're saying... grab our current location. Right. Yeah, okay. So we look at our current position, and so from our current position we're going to say, can we move left, can we move right, can we move up, and can we move down? And then of those possibilities we're going to store them away. Yeah. So we need to put the result into a memory space, because we are going to be using it quite a lot. So have we got any game storage? Have we got any spare space that we can use? I don't think we're using temps. But current frame. No, we're not going to use current frame. We'll put in here. A current available exits. There we go. So we're going to use that. Yeah, no, I don't want you. Is it that one? Let's get rid of that. No, it's not game constants. Go away. Group 1 game maze. There we go. Cool. It takes some getting used to this. Right, so we're going to store the result in there. Oh, come on, John. What? There we go. Right, so we are now going to check whether we can go the different directions, yeah? So we're going to compare with power 2, comma, DIR up. So we're going to compare it with that. Yep. If it's equal to 0, then it's not that. So we'll then check down. So I'll do this. Check down. Nico's wandering around. So we're going to load that. And we are going to do down. If it's not down, we're going to check left. Might as well grab that. Check left, which is direct left. And here is check right. And we'll check none. And this time we're going to say branch if equal. If it's none, it'll be 0. Yeah? Because we've got nowhere to go. So if we've come across a well, let's just say if we've come across a cell with 0 in it, that means we're in the middle of something where we're surrounded by walls and we've got nowhere to go. This should never happen, but I put it in just in case. I'll put exit there just for the sake of it. In fact, I won't. We'll do that. So, like we do here, we're going to do this. So, we've loaded it, we've checked if we can go up. If it's not equal to 0, that means we can go up because the up bit's set. So what we're going to say is we're going to go direction up, which should be 3. Yep. We're going to load how many exits, which is currently 0, and we're going to store it in the available exit array. Which means this is a possible exit. Hello, possible exit here. Woo! And we'll increase the exit. And then we will go... We'll jump somewhere. I'll just put that in for the moment. So we'll do the same for down. In fact, we don't need to. We can just run straight into that, can't we? Can check down, check left, and check right. Yeah, that works for me. Right, so do that, do that. If it's equal, bounce away. Hey, Stuart. So we're going to say if we can go down, if the bit's going down, we can go down. We can, whoops, we can go left. Left.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Oh, Stuart. Thanks for subscribing, mate. You are so generous to me. So generous. Thank you very much, mate. Thank you. Right. And right. So, they are our available exits. Now, we need to check if we can go that way. We need to check if we can go in that direction. Have we been there before? If we have, we can't say it's an available. It's a. We can't say is. Nico. He has a new symptom. I don't know if you've seen the video in Discord. He has a new symptom. I spoke about it at the start of the stream, mate. So if you want to, when I've finished, just watch the start 10 minutes of the stream, yeah? Then we could talk about it after. Right, so we're evaluating where we can go. So we're at this point. Can we go there, yeah? But before we can say we can go there, we need to check those places to see if we can go there, yeah? So this is where we grab this bit here, right? Because what we're going to do is here, we're going to say, is that up or is that right? Oh, that's right. So this is right. So here, we're going to say, compare. Right, where's my constants file? Have I got it here? Right, here we go. I've even put the constant in because I was thinking about it. We're going to use that bit for our... it's the solution path mask, but it's not. It's the actual where we've been part. So we're going to compare it with that. Yeah. If it's not equal to 0, then we can do that. We can go that way. In fact, it's probably better to say branch if equal to 0 to check none. That's better. That's better. So we increase X, we increase Y, and I am going to have to reload all that, aren't I? Yes. Because we destroy it when we do the check. There we go. So we're going to have to do that. Look at the next one. Have we been there before? Because we'll set that bit if we've been there before. No, we haven't. Right, that's an available exit. Right, so that's right. So this is left. So we will grab all this. And we'll do left. Which is here. So branch if equal to 0 to check right. So if we can't, even though we can go left, if we've been there already, so I need the compare. You looking for chocolate? Eh? There's no chocolate, mate. No, there isn't. I haven't dropped any today. I know. I ain't dropped any. I've got Nico hunting for chocolate. Got no chocolate, mate. Right. So we've done... Let's just get this right. This is going right. So right. This is going left. So left. Right. Left. Up. Up. What's the next one? Up. Yeah, it's definitely up. So let's go to the up part, which is here. Branch if equal to check down, because we don't want to say if we've been there. Oh, I need to put that this in. If we've been there, then we can't go there again, and then down. Down, 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 down. He lives in hope. He lives in hope. Put that there. So branch if equal to check left. Let's put the mask in. So now we are, so what we're doing, right, so here we are. We are loading, we're loading our current location. What is our current location's current state? We are checking, can we go up? Yes, we can. If so, look up. Have we been there before? No. Oh, hang on. That is meant to be not equal, isn't it? Let's change them. Yes, exactly. Good job, I'll go through this, isn't it? Right, so back again. Get the current location. Can we go up? Yes, we can. Look up. Have we been there before? Now, when we do that, it's going to be non-zero if we've been there before. That's where you get confused. If we're ending with that bit, if that bit is set, we've been there before, so it's not equal, so we bypass it. If it is equal to 0, we've not been there, so we've added to the available exits. Same with look down. Can we go down? Right, check down. Have we been there before? No, bypass it. Yes, bypass it. No, say we can go there. Same with right. Same with left. Right. No. Yes. So, what we need to do now is then eliminate. We got to eliminate where we've come from. Yeah, it's good because you guys are listening to my thought processes. Yeah, exactly. I'm doing it for my own good. So, there's another test we've got to do as well. Because we've got to test where we've come from. Yeah? We've got to test where we've come from. Now, the test of coming from is... Yes. Sort of. It depends what you define where you come from. You know, if it's the last place, then no. If it's you've been there, then yes. So we have to eliminate. We can't go back on ourselves, yeah? We can't go back. We can't. Of the available exits, if we've come from the right, then it means we can't go left, yeah? Understand? So, nothing to be proud of. Syntax error. So we need to have a direction. We need to have a direction. Where have we come from? Yeah. And so I can do that here because we've already got a direction, and we're not going to be using it until we start the game. Yeah. So we can use the direction, yeah, because we're not using that until we start the game. Once we've done the solve, we're never going to do the solve again because that'll be all stored in the maze array, yeah. So we now have to say, in fact, I think I should start at 1 and 1. Yes. I think I should start at 1 and 1. And LDX, so the previous direction would be going right. Because we would have, if you right, I'm looking at it from my point of view, but from your point of view, we're starting there, yeah. I don't know if it comes out right on the camera, so would it be starting there? Or starting there? No, it's starting there, isn't it? So we're starting there, but our first step will always be going right 1 to get to 1 1. So from 0 1 we go right to get to 1 1. So I'm predetermining our start position. He's back again. I'm predetermining our start position. We're starting, so our direction to get into the maze. Hello. Hello. What's the matter now? Hey? What's the matter now? Be careful. You're already the star of the show. You're trying to hog the limelight again. Hey? Go on. Alright then, mate. I'll fiddle with your ear for a bit. So we're starting at 1 1. Our previous direction to get to 1 1 will always be going right. So that's our start position. So what we can do now is we can test the corresponding things. So here, to check for going up, the question is, if we load storage, storage.direction. Oh, I've just moved up and I didn't mean to. And then test it with direction down. Right? So if we've come down, we can't go back up. Yeah? We've done that. We've been there, done that. Saw the biscuits. My little voice in the back of my head shouting at me. Hang on. The little voice in the back of my head saying we've already stored the direction. Oh yeah. Oh yeah. Oh yeah. Oh. Kill all humans. No, it's right. If you remember, the array consists of 2 parts. Yeah, the array consists of 2 parts. It consists of the upper and lower nibble. Now the lower nibble is basically telling us where we can go. Yeah. The upper nibble is telling us status of that cell, and what my brain is saying is that these two, we're using this bit to say we've been there. We'll also be storing the direction that we came from. Because we need to, from that location, that's where we would go back. Yeah. So, we need to this. Right, okay. We can do that. We can do that. Because we're going to be looping through this anyway. Element looper. This is the element looper. So what I need to do is... yeah, we can do that there. And we are going to OR it with no, I'll leave it as it is. You'll see what I mean. You'll see what I mean. We'll use the direction still. We'll use the direction still. Brain, shut up. So we need to compare with the direction whether we're going down. Yeah. If the direction is from down, branch if equal, then we need to bypass it. Check down. Because if we're looking up and we've come down, we don't want to say that's an available exit. Yeah. And we need to do the same for the other ones. So, can we go down? Yes, we can. Did we come from up? Yes, we did. So what's the next one? Left. Right, check left. Did we come from right? If we did, then we don't say the left. The left is a valid option. Yeah? And same with left. So this would be, have we come from left? Right, so let's run through this again. So we're all understanding. Grab our current location. Yeah? Does our current location say we can go up? Yes, it does. Right. Did we come from down? Was our last direction down? That means we was up here and we've come down. Yes, it was. Bypass it. No, it wasn't. Right. Have we been there? Look at that cell. Have we been there before? Yes, we have. Right. Bypass it. No, we haven't. Say it's an available exit. There we go. That's what we need to do, and we've done that on every one. By the way, I look in the merch store. You've now got beanies and caps to buy. Shameless self-promotion. Shameless. I did it. I did it yesterday. So there's beanies and caps in there. Shameless. Yeah, I've been thinking about that as well, mate. I've been thinking about that. I've got to... Oh, that's way more than my capabilities. Right. That's not a problem, mate. That's not a problem. Not a problem at all. Right, did I have a plus? Move plus. Or did I put them to be proper labels? Yeah, they're all proper labels, aren't they? Yeah. So now, we are now saying load how many exits. So, we're now saying how many exits are available to us. So, if we're at a junction where we can go in all. So if we've got four, so if we're in and we've got 4 available exits, one of them will be not available because we came from that way. So that means we can go there. We can go there, which means that we will mark it as we're moving there and store it. If we can't, you want a cap with that? I tried putting a cap. I tried putting the words on it, but it said that the words would be too small for the cap. That the available print space is too small. So you know it was warning me when I did it. So yeah, maybe I should just put plank exclamation mark. What are you laughing at? Are you laughing at me? Yeah. Mrs. OSK is listening. Maybe I should... What? Yeah. Do you want me to make one that says plank exclamation mark? I'll make it a limited edition one, yeah? Alright, I'll work on that. I'll work on that tomorrow. So, limited edition cap and beanie which says plank exclamation mark. That should work. But I did try putting what, but it was saying the writing's it's be too small. So I'll do that. I'll do it tomorrow. Right. So, how many exits we've got? If we're at a dead end, that means we've got no exits. There's only 4 of us anyway. Well, you know, limited edition. It'll be a really rare 4 planks, 5 including me. Right. So, have we got? Yes, we've got spaces to go. Okay. Then we load our position. Get them while they're hot, yes. We don't need to do that here. Right. This needs to be moved. Right. So, so if we've got available places, that's here. Load how many exits. Right, so we need some memory space, which is here. This is where this comes in. So I need that. There and there. So we're gonna randomize where we're gonna go. Yeah, because we've already tested that these are the ones we can go. And then we'll do the jump to that particular location. Yes, there was. Yes, there was. I think it was silent. It was a silent movie, wasn't it? No one spoke, I think. So, right. So what we need to do is we get our current location. We are going to jump to it. And oh, right, okay. Did I do a bit of Jamaican then? Dude, what's the matter? Right? Is it on YouTube? Just no speech. Yeah, I thought it was no one spoke. Alright, mate. Alright. There you go. So, what do we need to do? We need to say where we've come from. Right, we need to say where we've come from. Now we know that because we've got the direction. So I need to then our current place, we are going wherever we're going. So so we're going left, we're going right. Right, okay. So we need to store where we've come from. We need to store where we come from. We could do that here, I suppose. Yeah, we could do that there. Right, so what we're going to do is we're going to times our current location by 16. Let's have a look. If we're taking those two, then 2, 4, 6. No. 2, 4, 8. Starting there. 2, 4, 8, 16. Yeah, we've got to times it by 16. We've got to take the and times it by 16. Oh, that's thrown a spanner, hasn't it? Because I'm checking. Oh no, I'm checking direction. I'm not checking what's in it. Okay, yeah, we're fine. We're fine. Right, so I need to multiply it. So Logi ASL storage dot direction times by 2. Oh, where have I gone? Times by 2. Times by 4. 8. 16. So that should be effectively taking our binary number. So we'll say our binary number is, we're going to say our binary number is that. So we're going to say that 3 I think is down. 3 I think is down. No, that's 1. It must be up then. Yeah, 3 is up. Right. So we let's say we're going up. So we're multiplying it by 2. So it's 1, 2, 3, 4, 5, like that. And then we are doing that. Then we are doing that. And then we should end up with that. And that's what we want. Those 2 bits are set. So we are going to OR it with comma y, and then store it away. So we're taking the direction, we're multiplying it up so it puts it into this bit location here, and then we're storing it into the maze array. So we are ORing what we've got. In fact, that doesn't work, does it? Because we've already got it here, so we don't need to do this again. So we need to just OR storage dot direction and then store it away, and then do the jump. Yep, that works. So we don't need this. So if we've picked out that we're going left, we need to say direction left sta in storage dot direction. That's where we're going. So where's store location do? Update screen location. Okay. So that's looking ahead, but we're not looking ahead now. We are actually performing the task. So here we are. So here we are decrementing storage dot maze x, because we're changing the location to go back. So we don't need that. And we don't need that. Because we now need to reevaluate our new location. Yeah, that works for me. Right. Going right. So we're going right, store it in the direction so we can use it in the next iteration. This time we are increasing our X value. Get rid of that. Rem that out because I want to keep it. And we jump to the location. Yep, that looks right to me. Hey, WauloK. So this is going to be going up. This time we are decreasing Y. Don't need that. Trim that out because I want to keep it, but we don't need that. Okay, and this one is down. Oh, that's thrown. Copy. That's better. So this time we're going down, storing it in the direction, and increasing maze Y. Get rid of that. Rem that out because I want to keep it. Just in case. In fact, let's put this on everyone. Right, so up this update screen location. Right, we don't need that. We don't need that. But we do need to know where the colour location is. So we'll load our new location. We will JSR well, that's what I want. Going down, store location, here we go. Set maze location, work out maze array location. Must be in utils. Work out player location. No. Update screen location. No. Work out colour location. That's what we want. That's what we want. So we don't need to do that, and we need to do LD Y. So that needs to that needs to be LDY, and this needs to be LDX hash ZP color pointer. Work out color location. Right, then this can be here. So what we're doing is we're going to change the colour of where we are going. So we're going to change the colour to say purple, and then we're going to store it in ZP color pointer, comma Y. Don't need that. Don't need that because we're doing that. Oh, but what we do need to do... Oh, okay. Do we need to do that? No. Is he alright? He's chewing his feet again. Right, so we don't need this because we're doing this already. Right. So, if we... That is if we've got a place to go. Yeah, he's been chewing his feet for some reason. Yeah, he's been chewing his feet for some reason. He's probably high as a kite. Probably high as a kite. Right, so if we have... Right, let's rem this out. Let's rem that out, because I think that's not meant to be there. So we've checked that we can do a move, and we've performed the move, and then we go back round. Move to next location. I've got rid of that, didn't I? Yes, I got rid of that. Ooh. Oh, am I overthinking this again? I think I'm overthinking this again. I am, aren't I? Yeah. I'm overthinking this. So, store it away. We don't need to do all that. Load what we've got. Store the direction. Oh, we overwrite the direction. Right, okay. Okay, We'll have to use a temp. We'll have to use one of the temp storages as well. We'll use temp 7. That's it. Right, let's set the storage. So we don't need that. Don't need that. So we can get rid of all that. Because I'm overthinking it again. I'm overthinking it again. Don't need to do that. Branch if not equal to going right. That's what we need. Because the storage has already been set. Going down. Yeah, I suppose. Right. So we're not doing the jump. Right, let me just try and explain this. So we need to get rid of them two. And we need to divide by 16, which it is doing. And then we store it in the direction. So this is basically when we've run out of options. If we can't go anywhere, we need to look where we came back. So this is the track back. So we lowered our current position, which should be stored, which should have stored the where we came from. Yeah, should have stored where we came from. Did it store where we came from? The current position doesn't. We haven't stored that, have we? We haven't stored that. Because we store it and then move. That's what we do, innit? So we pick a random place, we store the direct, and we store it in our current maze location, and then we update the maze. And that's where we've come from. direction. If we're going down, we need to go up, don't we? Oh no, no. We're storing. Oh, hang on. Yeah, we're storing where we've come from, so we went right. So going back needs to say left. Rats. That's done a spanner. So this needs to change. Because we're not storing the direction. We're not storing the current direction we're going. We've got to store in the direction where we came from. And so that is wrong. That's fine. Easily sorted. So we're at that point. We've worked out as exits. We've now worked out our direction. So we need the opposite of that direction. How are we going to work that out? How are we going to work that out? How are we going to work that out? Right, dilemma. Where's my pad?
Oi, John, pay attention to chat.
Yeah, that's what I was just thinking. That's what I was just about to write that. Right, so what I'm thinking, as Andy's quite rightly says, right, let's see if this works, yeah? Oh, gotta switch it on. Here we go. So we've got four possible scenarios. 0, 0, 0, 1. 1, 0, 1, 1. So this equals left, up, right, down. So we want the opposite. We want the opposite of what we've got. And looking at it, we need to add 2, as Andy says. So left 0 plus 2. So left plus 2 equals 2, which equals right. Up plus 2 equals 3, which equals down. No, it's not a knot. It's not a knot, right? So let me wipe this. Truth table time. Right, truth table time. So we are looking at 0 0 0 1 1 0 1 1, and we want to end up with 0 2. Oops, no. Scrub. How do I erase? Click on that. So we want, come on. So we want to end up with 1. Oh, cry. It's really small, that was. One 0. This one needs to be 1 1. This one needs to be 0 1, and this one needs to be 0 0. Right? So it's not a knot. It's not a knot. But what it is it's add 2, add 2, add 2, add 2. And then, because if you add 2 to this, you're going to end up with... if you add 2 to that, then you end up with 1 0 1. So then we need to mask it for that. So we need to do an AND of that. The right is wrong. Right, left, up, right, down. Oh yeah, I see what you mean. That's wrong. So that would be that. So we're switching between those two, and we're switching between those two. Right? So as Andy says, we're adding 2 to get the opposite. Yeah? So we'll do that. Well done, Andy. There you go, mate. So, as Andy said, this here, we need to, so we're going to clear the carry. So we've stored the direction where we're going, but we need to store the opposite direction in the map, in the matrix. So we're going to add 2. Yeah. And then we're going to AND it like that. So that masks off any additional stuff. And then we'll store that in storage.temp7, which will then get added to the array. Here we go. Here we go. Good call, Andy. Good call. Good call. So Now we've stored the direction that we're going and the direction that we've been. When it comes to reevaluate, so when we move to the next cell, we know where we know where we go. Dear, going bonkers. At the current cell, we know there's no available exits. So I'm still not sure about that one, mate. Oh, we should be modifying the new one, shouldn't we? Shallan's moving. I was going to say, we need to set the opposite direction on the new place, not the old place. So that's not going to work. This is not going to work there. So we'll ram that out. We've got the direction and we've got where the opposite direction. So we need to then do the direction change. Then here we need to store the reverse of that direction. Yeah, that's what we need to do there. Because that cell is now saying if we went left to that cell, it should say we need to go right to go back. Got it. So, we also need to set the colour. Yeah, so we also need to set the colour. My arm hurts. So let's put a label there. And so if we're evaluating here, then we'll load purple and store it in the colour. But if we are backtracking, which is here, we are gonna. Can you remember what colour it was? It's not yellow, is it? It's green, isn't it? No, it's not green. That's the indicator. It's yellow, isn't it? The whole thing turns yellow. No, it isn't. Let's run it. I wonder if it'll run. Yeah, it does. Okay. Red. Right. It's red. The whole thing turns red. Right. No, yellow is the trail of us, the human. Yeah. What I'm trying to do is show. I'm trying to show where the trail the computer's going. So I'm going to make that purple. But when it backtracks, it's going to go. It's going to undo the purple and make it back to red. Yeah. So what we do is we set the colour to red. And then we are getting our current location, which is that needs to be rounded out. So we're getting our current location, which is where we are. Oh, we're blocked in. We've got no exits. So we load where we are. divide it by 60, and that tells us the direction to go back, and then we do the move back. So we do the move back to here, so we effectively go backwards. And because we've changed the colour to red, it sets the colour to red, so we don't need this. And then we go back to the start here and do it again. So we look at the available exits. Have we got an available exits? Have we been there? That's the thing that we're missing. Have we been there? That's the thing that we're missing. And we need to do that on the backtrack. We need to say on the backtrack, don't come here. We're having a go backwards. Right, so on the backtrack we need to... Right, this is the backtrack here. Right, okay, so we need to or hash oh, it's this. Or it with that, and then we need to set it back. Once we set it back, then we can and it get maze location. What 0 pets? That one. That's the one I want. I'm not going to do this set. I'm going to just do it straight off the bat. So I'm basically going to go store it back in there, comma Y. That would set. So when we backtrack, we read what is there and we say we've been here. This is it. We've done this one. Not going to do it again. Done, 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 done. Done. Go back. Right. So we've got no termination on this. We've got no way of defining if we've reached our goal, which is here. So what we need to do there is we need to test here. We need to test here. So we load our current position. We test it against. We test it against. Our endpoint. If we have not reached our endpoint, jump back round. If we have, jump out. Right. Okay. Let's see if it works. So, we're going to build the maze. And then we're going to solve it. Then we're going to just jump there so we can see. This is not going to work first time. I don't think this is going to work first time, but it's going to be interesting to see if it does it. Right, build. Oh, kaboom. I think that says ready. No. Right, let's put a breakpoint in there. Let's find out what's going on. Oh, why is it not adding the breakpoints? Right. Let's see what's going on. Right, so LDX2, that is going, that's direction right. Store it away, load our start points, load the end points. Yeah. Load our initializing. Oh, where is it? Ah, there it is. Initialize how many exits. Load our current position. Go away, grab what's there. Load what's there, it's 24. Store it away. Compare it with up. Are we equal? So it's saying we can go up. Is it? No, it's not equal. That's saying we can go up. Am I looking in the right place? Okay. Load direction. Are we going down? So it's now... Oh, hang on. Are we in build? We're in build again. We're in build. That's because I think it's because the screen didn't update. But I'm a bit concerned because... Oh no. Oh, it's me. I need to figure out if we're actually in the right place. Right, let's figure out if we're in the right place. Right, I need to figure out if I'm in the right place. So, if we do that, so store 1, X and Y, load the maximum, load that, load the current position, L, so it's 1 and 1, okay, PHP, store it away, load Y, which is 1. Right, ZP memory pointer, which is 70. Right, let's look at the memory. Let's look at memory 7. 70. 20, 28. 20, 28. Oh, is that? I wonder if it's there. I wonder if it's. Oh no, in this particular case it is going up. Is it? Right, let's load it. Let's see what it says. 12. So that's saying up only. No. That's saying right. Where are we looking? $20.28 is there. So that's the start. Next line. So that's the next line. But y is equal to 1, isn't it? So that's... Oh, yeah. 2028 plus 1. Okay. Oh, we haven't cleared it out. Hang on. We haven't cleared the map out. There. We haven't cleared the map out. So that can't be there. It's got to be there. Because we haven't set up the map. We haven't set up the map for the start. That's what's confusing me. Right, let's try that again. Right. Go away. Grab the locations. Here we go. So, what's at 70? 20, 28. Right, let's have a look. That's better. That's better. Right, so 7. So 7 is saying... Oh, hang on. Right, so 7 is saying that we can go right, up and left. Right, up and left. But we can't go up. Are we looking at the right, up and left? Am I looking in the right place? Must be. That is the first character on the screen. And we can only go right, down and left. So 7... 8 is 0111. So 7 is we can go left, we can go up, and we can go right. Well, that's a bit pants. Because we can't go up. Am I looking in the wrong place? Can't be. Alright, okay. Hey, Proton. So the next one is 5. So 5 is that. 4 and 1. So that's saying we can go right and left. I'm getting myself confused. Where's my constants? Oh, rats. I've got my numbers the wrong way round. Plank. Let's do that again. Right. 0, 0 is left. 0, 1 is down. 1, 0 is right. Shut up. 1 is up. Right. Okay. 0, 0, 0, 1. Right. We're on a winner now. So 7 is left, up, right, no down. No, 7 down, down, right, no up. That's right. That's right. So we're in the right place. Okay, I'm happy. We're looking at the right place. So we've come back with 7. You're going to put that phrase on a hotkey. So we store it away. We compare it with 8. Is that right? Oh yeah, up. So we're not doing up. We're definitely not doing up. But it says we are. Oh, I've got it wrong again, haven't I? I've got it wrong again. Right. Right. Let's work this out again. If it's equal to 0, go to down. Why didn't it go to down? Oh. Ugh. Go on, Mikroman, do it again. Go on. I'm waiting for it. Do it again. Yeah, I'm a plank. Thank you, SP. Thank you, Mikroman. Right, let's do this again. What an absolute wally. Plank. Right, so let's just run through it. Get the stuff. Load the location, which is 7. So 7 is left, right, and down. Yay! We're right. We're okay. Here we go. Right, and it with 8. Branch if equal to 0, which it is. Good. We're now doing it. Branch. Is it 2? And it with 2. Oh, it's not equal to 0. Right. Load our direction, which was 2. Compare it with 3. It's not equal to. Right, so we're allowed to do it. So that didn't do it. Oh, I've done it again. I've done it again. Oh, I've done it again. Oh, Ugh. Right, I'm just going to check that I've not done it again, alright? Stupid. Oh dear. Right. Dear. Oh dear. Done it again. F5. Oh dear. Right. Okay, so we're off again. Right, I think this is getting the next one. Yeah, and it with 40, which it's not equal to. Right, add it to the, right, the available exits. Yay! Do the next one. Add it to the exits. Yeah. Yeah. Now that's jumped straight out. Because it's now doing going left. Going right. It's not evaluated everything. Right, let me just run that again. Bless you. Right. Okay, so load. So we know now we're getting it the right info. Store it away. And it with 2. Check. Down. It is going down. Yes, it is. Load the direction. Was it up? No. Add it to the maze locations. So we do that. So it's loading the next one. Have we been there? No. Right, say we're going down. So we're adding down. Now we're doing left. Yep. Did we come from right? Yes, we did. So we've got to then bypass that, which we're doing. Are we? Is right available? Yes, it is. Load the direction. Did we come from the left? No, we didn't. Apply it to... Ooh. Oh no, it's checking. Right, okay, it's checking. Have we been there before? No, add that as a valid exit. Right. Number of exits. Have we got a number of exits? We have 3. DX. Load Y. Going to the randomizer. We have got a number and it picked 0. Transfer it into X. Load the exit, which is 1. How can that be 1? That's up. What is it? No, it's down. Right, okay. We're going down, boys and girls. Right, so we're going down. Store it. Add 2 makes 3. Store it in the temp. Load the purple. Store it away. load the direction. So we're now going in. We're going down. So going down. Here we are. Going down. Increase Y. Load Y. Get what's there. So this is the new location we're getting now, which is A. That's good. And we are taking our temp 7 and we're multiplying it up. Or in it. Nice. Store it away. Load our screen pointer. Work it out. Work out where the... So we're loading purple. And we're storing it on the screen. Okay, here we go. Nice! Now that's gone ahead. So that went ahead. Why did that go ahead? It decided to take a shortcut. Yeah. I've also thinking that I'm gonna start it in at the start.
Ladies and gentlemen, 6502 Kebab has entered the chat.
Hey Kebab. Right, so I'm going to start it at 0 there and 1. So we're gonna put it in the place. So we're starting it at the blocks. So our previous direction is no direction. No, we'll say it's right. We'll say we're coming from the right. We'll leave the previous direction there. So let's do it again. Oops. What are we on that one? Right, so I'm gonna put a breakpoint here on the looper, yeah. So we're gonna loop through it every time, yeah. So here we go. So we're gonna do the first one and make sure it's doing it right. So pick out what we're on, which is 04 and 04. 04 is right. We can only go right, which is correct. So no, we can't do that. No, we can't do that. No, we can't do that. Yes, we can do that. Did we come from left? No. Store it away. Right. Have we been here before? No. No. We've not been there before. Right. Add it to the array. So we load it, load the array, branch if not equal, decrease it, becomes 0. Load 3, go into the randomizer, get a random number. Keep getting a random number, keep getting a random number, come on. There we go. There we go. That's what we want. So we've got our random number, which is 0, because we only had 1. Maybe I should test for zeros. If we have, ignore the randomizer. It's a bit ridiculous having a randomizer for one item. Right, so we store it away, transfer it, load our direction, which is 2, which is... Why is it pick 2? We could only go right, which is 2. Store it away. Add 2, which is 4. That's 0, so that's left. That's the colour. We're not going left, we're going right. There we go. Get the position. Update our cell. So we're now adding, we've added that direction in. The direction which is 0, which is right. Okay. What are we doing now? Oh, we're doing the colour. Right, so we're now marking it on the map. To say we've done that one. Here we go. That's better. That's where we are. We've just moved. That's better. Are we at our end point? No. Jump here. Reset our available exits. Load our current position, which is now 1-1. Load, which is 07. So we're now at the purple location. So 7 says we can go left, right, and down. Okay, so and it with 08. 0. And it with 2. Yes, we can do that one. Did we come from 3? No, we came from 2. Add it to our array. Have we been there before? No. So we add it to the array. Now we're testing for 1. 1 is left. So we've come from the left. Is it equal? Yes, it is. Load our previous direction. Is it from the left? Yes. Bypass it. Nice. So we now know we're not going left. Good, 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 good. Load our direction. Is it 4? 4 is going right. Load our previous direction. Is it 0? No, it's not. Right. Look right. O3. So that would O3 means left and down. Yep, they're the only 2 exits. Right. Have we been there before? No. Add that. Right, so we've got 2 possible routes that we're going to pick. Going to the randomizer. There we go. So we are picking. We are going 1. We are going down, apparently. Yep. We're going down. So we're storing the opposite direction, which is up. Yep. Load in the colour. testing if we're going left, which we're not. Are we going right? No. Going up? No. Going down? Yes. Increase our Y. And now we're setting our direction for that one. Okay, so this should be still 7. Yep.
Stay there. I'm only going to turn the dishwasher off. Yeah.
You alright? Right, so we've got away. We are now adding, we are multiplying our previous direction, and we're going to OR it. Nice. And then store it away. Right. So, work out our colour location on the screen. Load Y, which is 2. That is not right. That is not right. Oh, Nico. Oh, it's a long story, mate. You've probably missed quite a bit. Let me just figure this out because I think that's wrong. I think that's going to put the colour. I think that's going to put the colour there. Yes, it did. Right. So that's one thing. Yeah, Nico's had more. I talked about it at the start of the stream, mate. So when I finish streaming, if you want to watch the first 10 minutes, I'll talk about Nico. Speak of the devil, and he shall appear. Hello. You alright? You alright? I speak of the angel. They want to know all about you, you know. Hey? Alright then. Let me get on with it. Yeah, he's up and about. If you look in my Discord, we've found that he's got a new symptom in general chat. If you look at the video, you'll see what I mean. Right, so colour. I think the colour step's wrong. Yeah, it is. It's meant to be that. Right, let's do that again. Here we go. Right, let's see. So we're going to step through it, right? I'm going to step through each cycle. So I'm going to put a breakpoint there. I'm going to step through each cycle. So here we go, F11. Right, F11. Right, so that's the first one. The first play is right. So, where's it going to go next? So it is definitely having issues. It's definitely having issues. Right, so I'm going to have to step through this and find out what's going on. Let's reload. So we know the first way through is right. So here we go. First way through is right. So we are now, so what we've only got one route, which is down and left. But we can't do left because we've already come from there. So let's make sure it's picking out the right place. 3. And 3 is down and left. Right, there we go. So we're not going there. Yeah. Right, so he's picked out that it can go down. So we didn't come from up. So we're checking down to make sure we've not been there. Right, and we haven't. Add it to the list. Then check 1, which is left. Yeah, we come from left, but we came right, so it's going to bypass it. Nice, it's done it. And that's ignored that. So we've only got 2 pots. We've only got, in fact, we've only got 1 outcome, haven't we? Which is down. Right, so DX, which is 0. That's right. Go into the randomizer, so we should only get a 0 out of it. There we go. Store that away. Load the direction, which is down. Add 2, which is 3. Store that in the direction that we need to go up. Set the colour. Now we actually perform the directional test. It's not 3, but it's 1. Increase Y. Load the new current location. OE. Or it with the previous direction, the way to go back. Yep. 3E. Load Y, set the colour, find the colour point. Why did that not set the colour point? We are at 2-1. Why did it not set the colour point? That's why. Plank. Plank, 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 plank. you and your F5, mate. Oh dear, I'll have a few planks today. Right, let's put the breakpoint here. I'm going to run through it one cycle at a time. Right, here we go. Purple. So we can only go one way. Next oh, here we go. Now we're talking. Purple. Purple. 2 possible outcomes. So let's put a breakpoint there. 2 possible outcomes. 7. So 7 is... Oh, there's 3 outcomes, isn't there? Yeah, down, left and right. Yep, that's right. Where you going? Right, we're going down. We're going down, fellas. So that means we'll have to go down again. Yes, we do. Right, this is where we're going to be doing the trace back. So this is going to be interesting. Right, so we load our bit, which is 38. Nice. So we shouldn't 8. So the only place we can go is up. But we should be able to say that we can't go up. Nice. And we shouldn't be able to do that, or that, or that. Load our index. Is it equal to 0? Yes, it is. Right. Here we go. So we're now, because we've got nowhere to go, it's now going to backtrack. So we're looking in our current location. Right. We're changing the colour to red. So we're going to get the current location, which is 38. We're going to OR it with 40, store it back to say we've been in this step, we've evaluated, and now we can't go there anymore. We're going to AND it with 30 to get our direction to go back. Divide it by 16, which is 3. We store it in the direction, and then we evaluate the direction. So we should, here are 3. Decrease, jump, now we can't do this. We shouldn't be doing this. Shouldn't be doing that. And now it's gone into a load 2, store it in 76. Right, okay, so so we need to blank out our current record. We need to blank out our current cell. Because at the moment it's blanked out the one we've just moved to. Right, so let's keep going. Let's see what it comes up with. Is it going round and round in circles? Yeah, it's not doing the backtracking properly, is it? So this is a problem here. So what I need to do, we can use the colour. Oh, genius, genius, John, genius. We can use the colour. Here, we can use the colour here. Absolute genius, John. Right. LDA. Oops. That. Compare it with red. Branch if equal to bypass. Because we don't want to do this. We don't want to do this. Alright. Because that destroys the data of the new cell. So we don't update the direction because we're backtracking, yeah? But we need to update, and same here. I think, in fact, let's get rid of that and put it there. Because we need to change the colour here. We need to change the current cell because we're moving away from the current cell. So we need to change the colour here. Not there. Here. We need to change the colour here. So let's grab that code. Let's grab this code. Put it there. Right. Where's that breakpoint I put? I want to move it. I don't want it there anymore. I want it here. Right, let's try this again. Right, we're going to loop through. We're going to loop through it in cycles, yeah. So here we go. So the first one, purple. Right, that's right. So it's only got one way to go, which is there. Right. So let's see where it's going to go now. So it went down, and it's gone down again. So this is the backtracking, yeah. So we're evaluating where we are. So this is our backtrack. So let's put a breakpoint there. Right, so we load this, we set the colour. So this is setting the colour of the current cell. Load A with 2, store it in colour, store. There we go, it's gone back to red. Clear the carry. Get the maze location. I am not sure that's got the right location. I'm definitely not sure that that's got the right location. So I'm going to put a breakpoint here. And I am going to grab that and that, because I don't think it was set up right. Right, here we go, let's try again. Here we go. Right, F11. And again. So we're going down. Okay, so we're going down. Let's see where we go next. Okay. So we're following that, are we? Okay. There we go. Right, so we've got to backtrack. Here we go. We're now in the backtrack. So we're going to change the colour to red. There we go. Then we're going to load the current position. Mark it that we've been there. Store it back. Now we're going to extract which direction we need to go back to, which is 2, which is right. Yeah, we're on a winner. And then it performs the right. So we should then go right. It should say we should be okay to do that. And we'll come back here. So it should then say, so evaluate our new position. So it says 25, which is right and left. That's correct. So so it won't evaluate that. It won't evaluate that. Here we go. Left. Is it equal? Did we come from the left? Yes. So it jumps out. The only way we can go is right. Have we been there before? No. Right. Add that to our direction. So we've got to go right now. Okay. Ah, this is wrong, isn't it? It's only doing one backtrack. Okay. What's up, mate? Okay. What? What? What was that for? What? You want to come up here? You want to say hello, do you? Right? Hey? You want to say hello? Well, say hello then. No? You want to say hello? No? Hey. You're soft, aren't you? Yeah. Daddy's soft as well. Yeah? Oh, what's the moaning for? Hmm? Alright, let's put you down. There you go. What's the matter? Hey? What's the matter? No? Alright, you stay there then. You stay there. Wolf bark wolf, yeah, yeah. I have not figured that out yet, mate. I've not figured that out. Right, we've got a problem with the backtrack. Right, because the problem with the backtrack at the moment, it's evaluating all the possible exits and it shouldn't be doing that.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Amok! Welcome! 13 months! Man! Wow! I think there's only one person beating you on the subscriptions, and I think that's Mikroman. Welcome! Right, so we got a problem with the we've got a problem with the trace back. I think it's because it's evaluating all the possible directions again, and we shouldn't be doing that. So right, so how am I gonna? So I need to stop it evaluating all the directions. I just need it to. How are we gonna do that? How are we gonna do that? But we need to make it evaluate the directions. So why is it not marking it?
Hi, John here. Another subscriber. Stay a while. Stay forever.
WauloK, thank you, mate. It's much appreciated. Thank you very much for subscribing. 3 months for you. But you've got an excuse. You're a time traveller. You're ahead of us, aren't you? You're in the future. Thank you. Right. Okay. So when we trace back, that is the problem. That is the problem. Yes, you are. You are a patron, mate. A patron for a very long time as well. Very long time. So we have to evaluate which way we go. The problem is, yes, the problem is if we double back on our, right, okay. Where's me pad? Where's me thing? No. Right. So, let's see. Are we switched on? Yes, we are. Borders. Right. So here's our maze. Right. And let's say we've got a way down there, a way down there, a way up there. But here it's dead, right? That's a dead end. So what we're doing, we are recording that we're coming this way, this way. Hey, Mr. Kebab, thank you very much for the bits, mate. Thank you very much. Cheers. Oh, we've got a hypertrain going. We have a hypertrain going. Again, we had that last time, didn't we? So we come here. And we're recording that we have to go back, we have to go that way. Yeah? So when we get here, and then here, Mark, level 1 of the hypertrain's done. Yay, well done, guys. Well done. Oh, Mikroman, thank you very much for the bits. — 28% of level 2. Wow. So here, when we're here, we are then saying, we can't go any further, so we read this and then mark that as done. Yeah, so then we move back to here. We move back to this position here. Now the problem is we then evaluate which way we can go. So we say, can we go here? Yes, we can, but we can't because we've marked it. So the only way we can go is this way. Yeah. So then it comes back and changes that, right? Oh, why is it? Come on. There we go. And changes that to now become that way, because it's now going that way. And so I think it's doing this. I think it's just going round and round and round and round. So we need to, I think we may have to check this. Because we can't have it going backwards and forwards, backwards and forwards. Because technically this here Oh, why is it? My pen is playing up. Oh, I don't know what mode I've put it in. Here we go. So, technically, when we do that way, and we mark it to say we go in that direction, when we've moved back, we need to then say, look back again and say, oh, we've got this marked, we've got to go back, because basically oh, it's difficult to try and explain. We can't reevaluate where we're going, because if we go that way, right, we changed that goes in that direction, and we shouldn't be, because effectively this is the next block. You know, we are blocked in. We can't go anywhere. So it should say I'm blocked, and then go back again. I'm blocked, and go back again. Yes, that's the problem. So here, where we are getting, so we're getting, we may have to. We may have to. Because I don't want it to. Don't want it to go back on itself. I want it to be able to say we can't go that way. Well done, guys, for getting level 1, mate. Yeah, well done. Well done. All right, okay. Yeah, that's basically what I'm trying to do. Yeah, that's basically what I'm trying to do. So, so it's the trace back that's the problem. Yeah, exactly. So, so the trace back would determine which way we're going back, and when we come to, we're not updating the back, but what we are doing is when we load here, so when we're back here, we get the location, so it'll say, oh, we can go left and right. Can't go left, so we have to go right. But the problem, mate, should I? Yeah, we're gonna have to have another array. We're gonna have to have another array because we haven't got enough. We haven't got enough data in. Well, hang on a sec. Hang on a sec. If we can say we've... If we can say we've been there... then there's effectively no route. If we can say we've been there. I'm just trying to think. When we do the back, and then we get the current location. We don't test to see if we've been there before. We just see what available exits have we got. So if we can say, if we say oh, how can we determine if we've been there but not been there? We set the bit at the current location. That's how we do it. Right, so where we're setting this to say we've, where are we? Where is it? Here. Where we're setting here, I think we should set it on every one that we touch. So let's rem that out, and we'll go down here and we'll change it to set on every one that we touch. Right, let's try that. But okay. I think I'm going to have a problem here, but we'll work through it. Right, so okay. Right, so we're at the track back. So this should then fire the track back, which it has. There we go. So we load that we go, and we're going back. Right, that seems to be working. Has it gone back? Yes, it's now it went back, and now it's evaluating a different line. Okay. Okay. Oh, lovely. Right, this'll let me know if it works. Backtrack. 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 Here we go. Now it should say, "Ooh, we've got away." Yes. Oh, nice. Oh, it should have said we'd done it. It should have said, oh, the test failed. So it's just going to carry on. It should have said, right, okay, so we got a problem with our test. Right, let's load that again. Right, here we go. So, F11. So it's doing the trackbacks. Right, it's tracking back. It doesn't like that way. Now it's trying a different way. No. No. Oh, this is so cool. There. It's there. It didn't go. It didn't flag it. It didn't flag it. Right. Let's put a breakpoint there. Find out what's going on. It's here. It's here. It should have dropped out. Let's put a breakpoint there. Right, do it again. I'm just keeping my finger on F11. So it doesn't like that way. Going around the houses, isn't it? Oh, here we go. Right, here we go. So it's going to backtrack. Go ahead. Down. There. Why is it not? Why is it not picked it up? Why is it not picked it up? Oh! It's not picked it up because it's one less. Well, it's not one less on X, but it's one less on Y. Ugh. Well, we know the backtracking's working. Right, let's try this again. There is a problem. While I was watching it, we still have a problem. We're still not recording our route. We're still not recording our route. Let's see if it comes out first. So let's see if it... Let's see if it comes out. Come on. Well, that's a dead end. Here we go. Oh, it's gone up. Oh, it's gone up. Right, here we go. Down you go. Here we go. Does it come out? Yes, it does. There we go. That's the route. So, right, okay, let's take the breakpoints out. Let's run this without any breakpoints. Let's see what it's like in real speed. Right, here we go. There we go. Oh, so cool. So, that was quick as well. Let's do that again. Oops. Well, that was fast. Right, now the problem is we're not recording our route. So we need to record our route, yeah? So at the moment we're just eliminating the squares, but we're not actually recording our route. So let's record the route, and what I need to do is we need to just change the constants. Here we go, game constants, that's the one I want, because this is meant to be the solution path, and at the moment we're using that as the elimination path. So what I'm going to do is I'm going to use this as the elimination path. So in here we're going to do a quick find and replace for, that's what we want and that's what we're looking for. Yeah, so we've got 6 of them, so we've got one there. That's it. That's done them all. So that's using the maze path. And now what we need to do is with the when we do the backtrack, we need to. I've got to think this right. We set it. We set it, and then we've got to turn it off. That's what we need to do. We set it and then turn it off. So down here, where we set where we've gone. Where is it? Where do we set it? I've forgotten where I put it. There. Right. We also set the solution path. Yep. So we set both of them, and then when we do the backtrack, we turn off that particular. We turn off that flag because it's not part of the solution, right? So where's the backtrack? There it is. So here, right, we don't do it. We AND it with 255 minus that. Is it 255? 255 minus 0 is all of them switched on. Yeah, right. And then store it back. So we're then turning it off as we go as we return back. Yeah. Then on our right, this is gonna be cool. This is right. So I've just shut down the wrong file. Hang on. So if I need to go back in game maze, here we go. So we've got a routine that clears out all the array information, yeah? I think. We've got a routine that clears it out. Hang on, let me find it. Set up for start. Clear maze, right. Clear trace maze. So what we need to do then is we need to create another one. We create another one that does exactly the same thing but clears the player trace array. So basically in fact we do that because we want to keep the solution bit in there. So we want to keep the solution path in there. Right. So let's add that to our code. So we resolve the maze, then we clear the information bar not including the solution. Now, that makes the maze invisible, that makes it 3D, update maze. Where's the helper? Where's the routine that we did for helping? Where it shows the maze on help. Let's look in game controls. Game controls. Help. Hey, here we go. H. Maze.draw maze. That's what we want. Maze.draw maze. So draw maze. Here we go. Right. So we load the maze pointer. It's here. This is the one. So we BIMI for the player, and then and with not that, with that. and branch if not equal. If it's not equal, then we want to say make purple. Make purple. Right, so if it's not equal to 0, then we want to go jump to make purple. And then do this. Right. The test is now is to clear the screen and then draw the maze. Draw maze. Right. So what's going to happen is, right, we'll put a stopper in it so we can see what's going to happen, right? And then we'll press a space, it will clear the screen, and then it should draw the maze, and the maze should contain the solution path. Right. So that's the solution path. So I'll press a key. And the crowd goes wild. Right, that's working. That's working. Right, let's get rid of that. Let's get rid of that. Get rid of that. So, what mode are we in? We're in easy. Let's go into medium. Right, let's do this for real. There we go. It's worked out. It's worked out the solution. So let's do a little bit of moving. Right. Here we go. Help. Does it show us the solution? Oh, did I do help for medium? Did we do the help for medium? No, we did it for hard, didn't we? Let's do it again. We ought to do help for medium, I think. Right, this. Wow. Okay. Oh, that's thrown a spanner, hasn't it? Why did that not work? That's pausing, and I don't know why it's pausing. Oh, that's because of this here. Okay. So we're storing the direction. Are we initializing the player? Yes, we are, which is there. Oh, have I broken something? It's not running now, is it? CPU jam. 217A. Well, that's interesting. Where is it? What? How come it's jumping there? Let's have a look in there. Initialize 3D maze. Hang on. Maze.init 3D maze. Okay, have I overwritten? Here we go. What have I done? Oh, it's doing that. Okay, so it's doing that. So it stalls doing this then. Maze.update 3D maze. Why? There's nothing in there to... There's nothing in there to throw a spanner. Oh, hang on. Position Y, position X. Oh, I think it's that. Hang on. Where do I set up the window? Oh, I wonder if it's in there. Hang on. Maze setup. Maze setup. Here we go. Okay. So it's not... So it's not that. It can't be the setup, but I think it's to do with the fact of the... I think it's to do with the windowing in update. Here. I think it's something to do with that. Because we're... Position X and position Y is what we used, but we... player. We reset that, that's fine. Update maze. I wonder where this is crashing. Okay. Right. F10. Let's find out where it's crashing. Breakpoint. F11. Oh, CPU jam. Where's he doing that? Can we rewind this? How can we rewind? Right, so the timer stopped. Alright, okay. I'm just trying to find where it's killing, where it's jumping to this spot, because now it's jumping to 2182. Let's put a... So it's doing the timer and then it hangs. I think it's to do with this. Let's put a breakpoint in there. Right, so it's made it there. Okay, F10. What's it doing? Ooh. What's gone on there? Oh, we've overrun into the maze array. Hang on, we've overrun into the maze array. So we'll put the maze array at Alt F10 to go back. Yeah, we've assembled into the maze array. That's why it's gone. So we'll put the maze array into into 4000. We'll put the maze array into 4000. Here, let's put it into 4000. I think that's why it fell over. We've assembled into the maze array. There we go. Right. So we're just gonna make some simple. There we go. I'm gonna make myself get blocked in. Oh dear, I'm lost. I wonder if help will help me out. There you go. And it tells you the solution. How cool is that? How cool is that? We now can do the solution. Oh, I'm just so chuffed with that. Right, let's put it in easy mode. Because I just want... I just want to see it do it. I just want to see it do it. Every time. Hang on, let me do this. And we'll send it back to the beginning. It's quick. Oh, I'm so pleased about this. Nice. Nice. Oh, that was quick. They are. Some of them are evil. Oh, look at that one. Can you imagine that one being in hard mode? Oh, that's a nice straightforward one. Oh, can you imagine being in hard mode? And you'd be convincing yourself that you're going into a block. Oh, that's a nasty one. That is. Oh, it scanned a lot of the maze there, didn't it? Oh! Oh, that's a nasty... Oh, that is a nasty one. Oh, that is nasty. Because you'd go down it and you're backtracking and you're thinking, oh, have I gone the right way? So, do you think purple's the right colour for the thing, for the solution? Well, I was challenged to make to write some code to solve this maze. There we go. Look at this. Look at this. How did that get turned off? Anyway, right, okay, so let's go back. I don't know how that got turned off. With excitement, yeah. So, the solution we've used... the solution we've used is recursive backtracing, yeah? So, so we evaluate the place, we come to a block, a dead end, we backtrace until we've got another way out, yeah? We are not using the stack for our recursion, we are using the actual maze array to utilize the recursive bit of it, because we set aliens, because we set the data inside the array. So that is what our recursion, because we recursively step back through the steps that we've done. We don't add it to the stack. I mean, I could have implemented a stack version, but I didn't see the point when we have got a way of implementing recursion without having to blow up the stack. So we recursively go back and then we evaluate the next thing. I think the only thing that we needed to do with this is that if we've got one way out, we shouldn't need to use the random function. So let's do that, because that is just going into the randomization function for no reason whatsoever. So let's just quickly here, right? So we dex, and if it's equal to 0, we don't need to. We don't need to do it. Yeah, branch if equal to 0. No need to randomize. And we just basically do that here, because it's 0 anyway. Because if there's only one outcome, we dex it to 0. If it's equal to 0, we don't need to randomize it. So that might actually make it a little bit quicker. Oh, it is. That is a lot quicker. Ouch! That's an evil one. That is an evil one. Ouch! Oh, I love watching this do it. Right then, guys. Challenge was accepted. Challenge completed. We have now got in the help screen, we now can show the user the solution. Ship it. So, yeah. And this is why I did this today and not Hunchback, because someone challenged me and I thought, I'm not having this. I'm not having been challenged, and then they go, oh, you're too scared. Well, no, here it is. And it does. It does the beans. We've had a few hiccups on the way, but it does the beans. Oh, I'm loving this. Look at that. Ooh, that's an evil one. That is an evil one. Alright, guys. A C64 saver. Yeah. Screensaver. I could watch this all day. Oh, that is nasty. That is nasty. that would have been painful in hard. I think it would have been painful in easy. Right then, guys. I think we've accomplished what we set out to do, which was to make the help system have the solution involved as well. So what we'll do is if we put the solution up, we're going to have to make it really painful if they have the solution in the game. But yeah, I hope you've enjoyed that. I hope you've learnt something as well, because this, like I say, there is recursion in this, but it's not using the stack to do the recursive. It's used the array to do the recursion, and we've just followed the progress. Thank you very much for watching. No problem, Aquafin. I hope you've enjoyed yourself, and thank you for the subs and the bits, guys. It was great, and I will see you on Monday. He's asleep. He's asleep. Alright, guys. Night night, and I'll see you next time. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.